Hello. Today I'm gonna tackle wireless connectivity problems through visible light communication. So one day I was on a flight and I had to urgently send an important email, but there was no available Wi-Fi on the aircraft. So I asked myself, why airplanes do not offer free high-speed internet connection yet? And one of the main reasons is that Wi-Fi operates using the radio frequency signals which have a limited spectrum range. So that means the more people who are trying to use the Wi-Fi, the slower and less reliable it becomes, similar to how pizza gets smaller with each slice taken. Another reason is that Wi-Fi signals can interfere with sensitive airplane systems, creating a safety issue. And these problems are general for RF technology. But what if I told you that there is a solution that can solve both of these problems? And this solution is called visible light communication, or shortly VLC. So in VLC, the transmitters are the light-emitting diodes, which can transmit data by modulating the light intensity at a very high speed. On the other end, there are photodetectors, which can detect the small variations in the light intensity and then transform them into the electrical signals. So one of the main advantages of the VLC is that it operates using the visible light spectrum, which has a much larger spectrum range compared to the RF. Also, it doesn't produce any electromagnetic interference, and it is very energy and cost efficient because it provides illumination and data transmission at the same time. But one of the major limitations in designing practical high data rate VLC systems is the narrow modulation bandwidth of the LED itself. So our goal is to explore innovative technologies in order to improve the spectral efficiency of VLC systems. So in other words, we want to transmit as much data as possible per given bandwidth. So our vision is that the conventional VLC systems use uniform distribution for data transmission, and this creates a rate loss. And in order to mitigate that loss, we propose to use a non-uniform distribution for data transmission, and this technique is called probabilistic shaping. So in our work, we propose 3 novel adaptive coded modulation schemes for different scenarios: for single user, for multi-users, for the MIMO case, and also we designed the prototype for the transmitter for VLC systems. So on this slide you can see the performance of the proposed scheme in terms of the transmission rate. So as you can see here, the solid line is the capacity of the VLC systems. So this is like a theoretical upper limit. We cannot transmit data higher than that. The dashed red and blue lines are the transmission rates for the proposed and the conventional schemes respectively. So as you can see, the proposed schemes operates very close to the upper limit, and it outperforms the conventional scheme. On this slide you can see the transmitter prototype for the VLC systems. It consists of the FPGA, digital to analog converters, the driving circuits to drive the LED currents, and the LED itself. So to conclude, probabilistic shaping can be used to achieve the fundamental limits of the visible light communication systems in terms of the transmission rate. It also helps to outperform the conventional schemes in terms of the spectral efficiency and the frame error rate. And finally, it enables more efficient and reliable VLC communication. Thank you.